Hello, in this lecture, you are going to study Introduction of Microcontroller. Objectives of this lecture are concept of microprocessor and microcontroller, difference between microprocessor and microcontroller, difference between Harvard architecture and von Neumann architecture, and difference between CISC and RISC machine. Functions of both microprocessor and microcontroller are same. Both are digital devices, so they work on binary number system, which includes 1 and 0 digits. They can perform arithmetic operations such as addition, subtraction, multiplication, division, and logical operations such as AND, OR, NOT. Now, these devices can perform these operations according to the instructions given by user. Now, set of instruction is called a program. So, according to program written by a user, this processor, microprocessor or microcontroller performs the different operations. Let us understand the difference between microprocessor and microcontroller. Microprocessor has central processing unit, that is CPU. The CPU consists of arithmetic logic unit, that is ALU. Along with this ALU, there are few registers. Accumulator is generally associated with ALU. These registers are used to store data. This CPU also has a control unit. This control unit generates different control signal such as write signal, read signal, chip select signal, and so on. To use this microprocessor for any application, we have to interface devices externally such as memory, ports, interrupts, timers, serial communication block. Then only we can use processor for application. Whereas microcontroller consists of arithmetic logic unit, register, control unit, and it also has internal memory such as RAM memory, which is used to store data, read-only memory, that is ROM memory, which is used to store a program, that is instructions. It has inbuilt timers, which are generally used for delay generation or counting external events. It has serial communication block, which is used to transmit and receive data serially. It has interrupts. It has watchdog timer, which is used to protect this microcontroller. It has ports where we can connect or interface input-output devices directly. So with this microcontroller chip, we can directly build any application. So this is main difference between microprocessor and microcontroller. Diagram shows typical microprocessor based system. The system consists of microprocessor, that is CPU, and the external devices like ROM memory, RAM memory, and IO port. These devices are connected externally to CPU through connections, and these connections are called as the buses. There are three buses: address bus, data bus, and control bus. More about these buses we'll discuss in next lecture. We can interface input and output devices to microprocessor through IO ports. To synchronize this data transfer operation, clock is connected to CPU. So this is typical microprocessor based system where all devices are connected or interfaced externally. Microprocessor based systems are more flexible. In microprocessor systems, we are interfacing all devices externally, such as memory, serial communication, timer, depends upon our application. So selection of these external devices also depends upon application. If we want to use serial communication in the system, then only we'll interface serial communication block. If we need timer in our application, then only we'll interface timer externally. The size of memory also depends upon our application. Suppose size of our program is 2 kilobyte, then we'll interface memory of size 2 kilobyte. So design of microprocessor based system depends upon application, so it is more flexible. Whereas in microcontroller based system, everything is available internally. So even if I want to use the ROM memory of 2 kilobyte, size, but if internal ROM is of 4 kilobyte, then that will be available with my system. So we cannot select a block as per our application. Whatever blocks are available internally, that our system consists of this block. So microcontroller based systems are less flexible than microprocessor based systems. Microprocessor based systems are used for general purpose applications such as desktop computers, laptop, notepads, etc. All these devices we can use for any application. For example, desktop computer we can use for PowerPoint presentation, for word processing, for writing a program in C, C++, or for writing a program in Python. So for many applications we can use this system. Whereas microcontroller based systems are used for some dedicated applications. For example, the keyboard is one of the microcontroller based system. Printer is one of the microcontroller based system. Printer system is used only for dedicated application such as printing a job. Same for mouse, washing machine, digicam, pen drive, and lot more systems are available which uses a microcontroller. So microcontrollers are generally used for embedded system which are developed for some dedicated application. Von Neumann architecture. Von Neumann architecture is named after scientist John von Neumann. This architecture consists of one single memory unit. This memory unit is shared to store a data as well as to instruction. Since there is one single memory unit, one bus is available for communication between CPU and memory unit. Because of this, the speed of instruction execution is slower in von Neumann architecture. But because of single memory unit, the architecture is simple and it is also cheaper. Harvard architecture has two separate memory blocks. One memory block is to store the instruction, which is called as the instruction memory, and second memory block is used to store data, which is called as a data memory block. There are two separate buses to interface instruction memory and data memory. Because of this, the speed of execution of instruction is faster in Harvard architecture than von Neumann architecture. Most of the modern computing architectures are based on Harvard architecture. Now, due to the separate instruction and data memory, the Harvard architecture is complicated and cost of this architecture is comparatively high. Let us understand difference between RISC machine and CISC machine. RISC stands for Reduced Instruction Set Computing, while CISC stands for Complex Instruction Set Computing. RISC machine has less number of instructions, while CISC machine has more instructions and the instructions are complex. Less addressing modes are used in RISC machine, whereas more addressing modes are used in CISC machine. All the instructions are having same size in RISC machine. Maybe all instructions are of 1 byte size. So each instruction require only one machine cycle in RISC machine. Whereas to execute the instruction may require 2 to 10 machine cycles in CISC machine. The hardware of RISC machine is simpler and manufacturing cost is also less. Whereas hardware of CISC machine is complex and cost is also higher. Power consumption in RISC machine is lower, whereas power consumption in CISC machine is higher. Examples of RISC machines are PIC microcontroller, ARM processor, whereas examples of CISC machine are 8086 processor, Pentium processor, 8051 microcontroller. Thank you for watching this video.